Wow, 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 wow. Beautiful, beautiful, beautiful. This is the God Presentation Center, and today we are going to be studying machines. All of us already we know or we have heard of the term machine, but some of us we don't even know what a machine is. In this beautiful lesson and presentation, I'll be here to explain to you what a machine is and how this truly matters to our everyday life. As a physicist, it's very important to understand every single thing about machines. So I want you to stay to the end so that you understand every single term and formula you need to pass your physics exam on machines. So without wasting time, let's dive in. What is a machine? A machine is simply a device that uses energy to make work easier by changing the size or direction of a force or performing tasks automatically. And I'm sure you've seen something there. We have types. Before we can talk of any types of machines we know, it's important that we know the types of what? Of machines we have. What are these types? Before you dive in, there are two types of machines: simple machines and compound machines. And simple machines may include something like this: a lever, a pulley, wheel and axle, an inclined plane, a wedge, or a screw. These are just basic devices with few or no moving parts. Simple machines, right? Good. So the other type is called the compound machines. These may include bicycles, cars, washing machines, computers, and all those big machines you see, cranes and many more. So a compound machines is made by combining two or more simple machines. That is it about machine. But in this beautiful lesson, I want you to understand what truly a machine does. You know, a machine is a force multiplier, meaning you're going to apply a small force to get a bigger output. So now, how do we calculate this? Before we go further, let's understand the terms associated with machines. Under this section, it's very important to understand the terms you will be using on simple machines or simply machines, like velocity ratio, also known as the speed ratio, mechanical advantage, and the efficiency. So it's very important that you know their definition and the formulas of all of these things right here for you to pass your physics examination. So let's start with velocity ratio. Velocity ratio is the ratio of distance moved by the effort to the distance moved by the load in a machine. In our case here, we have the distance moved by the effort here and the distance moved by the what? The load here. And we are seeing that the velocity ratio is given by the formula distance moved by the effort over distance moved by the load. So look at it here. In this beautiful example here, we have got the distance moved by the effort and the distance moved by what? By the load. And of course, that is all about velocity ratio, right? Now, we are saying something about this. The velocity ratio is always equal to the ideal mechanical advantage. And that's why here in this example, we have shown it by what? By simply using IMA, which represents ideal mechanical advantage, which is distance moved by the load over distance moved by the what? Distance moved by the effort over distance moved by the load. That is it. Another thing you must be able to understand carefully is that the velocity ratio is a ratio, and so it has no units. With this understanding, let's move forward to understand what mechanical advantage is. What is mechanical advantage, MA? Mechanical advantage, MA, is the ratio of the load lifted by the machine to the effort applied to lift it. it tells us the number of times a machine multiplies the force applied to it. It also tells us how much easier a machine makes work. And mechanical advantage is given by the formula MA, which is mechanical advantage, which is equal to load over effort. You can see right here from this simple example we're having in the corner. To find mechanical advantage, we are going to be dividing our load by our effort, or simply our load by our effort. That's how we get our mechanical advantage. So let's move forward to understand efficiency. Efficiency is the measure of how well a machine converts the input work or energy into useful output work or energy. These terms are important. So when you're talking about efficiency, you're talking about how well a machine converts the input energy into useful output energy. Right? And then it tells us how much of energy supplied to a machine is converted into useful work. Right? And it is given by the formula mechanical advantage MA over velocity ratio times 100%. Or it is also given by efficiency, which is equal to actual mechanical advantage AMA over ideal mechanical advantage IMA times 100%. Now, before you go, let me give you what you need to understand about those terms I just mentioned, like ideal mechanical advantage, which is the frictionless theoretical advantage. It is the mechanical advantage with no energy losses, and it is always equal to the velocity ratio. That is mechanical advantage, which is ideal. It is given by the formula distance moved by the effort over distance moved by a load. Actual mechanical advantage. It is a real machine advantage. This is the real force multiplication achieved by a machine. I'll say it again. This is the real force multiplication achieved by a machine. And it is given by AMA, which represents the actual mechanical advantage, which is equal to load over effort. In practice, you should always remember that an actual mechanical advantage is always less than the ideal mechanical advantage. So if you enjoyed this video, consider subscribing, liking, and turning on the notification bell there so that you don't miss any future videos from this channel. Otherwise, thank you very much for your time. Let's pass physics together. Enjoy.